Hey students, it's me, Mr. Fitz. So some of you have asked me to make some videos on angle of elevation and angle of depression problems and trigonometry. So here we go. They like to do a lot of problems about boats. So here's some boats here. So let's take a look at some of those problems. So let me just pull up the problems here. Okay, so they love these like stories, right, with these problems. So that's why I said once upon a time. So once upon a time, a boat was heading towards a lighthouse. So whose beacon light was 140 feet above the water. The crew measures the angle of elevation to the beacon as 10 degrees. What is the ship's horizontal distance from the lighthouse? Okay, so here's the lighthouse. Here's the beacon right here. Here's the ship. Feel free to use this drawing for something else. This is my fine artistic work here. I apologize, the air conditioners make a little noise. So let's take a look. So first of all, what do we know? They told us the angle of elevation is right here. So when we think about angle of elevation, we're always kind of like looking up. So that's why I like drew it like this way. So it's kind of like looking up. So here's our horizontal distance. Let's go ahead and label that. There's our horizontal distance there. Think of like the horizon, right? That's our horizontal distance. And here's our angle of elevation. And then this is the height of the lighthouse right here, is 140 feet above water. And so this is a right angle. And so this is a right triangle problem. This is a trigonometry problem. So let's go ahead and set it up. SOHCAHTOA. Don't forget SOHCAHTOA, right? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So if this is my reference angle, this is my point of reference, right? I'm sitting here on the ship and measured this angle of elevation as 10 degrees. By the way, they actually have devices that do that. It's called a sextant. It's pretty cool. Anyway, and then here's the height. Let's go ahead and label our triangle. Here's the hypotenuse. Here's the adjacent side, and here's the opposite side. All right, so we know the opposite side. We're looking for the adjacent side. The hypotenuse has nothing to do with this problem. So which of these do we have to use? Tangent. So the tangent of 10 degrees, which is our angle of elevation, equals the length of the opposite side, 140, over the length of the adjacent side, which is x. Okay, well, I can just, this is just a number. I can plug it into my calculator. It's just a number. Tangent of 10 degrees equals 140 over x. We can cross multiply. Can put that over 1 and then cross multiply. And what that leaves me with is x times the tangent of 10 degrees equals 140. Divide both sides by the tangent of 10 degrees. And what you're left with is x equals 140 divided by the tangent of 10 degrees. So let's go ahead and bring up our graphing calculator. I'm going to go ahead and plug that in so you can see it. Okay, so here's our graphing calculator. One thing to remember, make sure you're in degree mode. So if you hit mode, make sure you're in degree mode. I am. So what I'm going to do is it was 140 divided by the tangent of 10 degrees. And that's 794 feet approximately. And I could round that. Also, if you wanted to, what you can do is, here, let me hit enter. If you want to enter that as a fraction, if you hit this alpha y equals right here, you can actually enter that in as a fraction. So it'd be 140 over tangent of 10 degrees. And that's 793.97. If you need to round that to say the nearest whole number, you could use the math round function. And let's bring that up. Second answer, comma, say 0 decimal places, enter, 794 feet. Okay, cool. Let's take a look at another problem. So yeah, that was 794 feet was for that one. All right, so let's take a look at one more problem. we're going to look at an angle of depression problem. So let's look at that one. So this one, they've changed the story. So from now, we're actually looking from the observation deck of a skyscraper. A SEEF measures the angle of depression to a ship below to be 67 degrees. If the observation deck is 945 feet high, what is the horizontal distance from the base of the skyscraper to the ship? Okay. So just imagine a SEEF is standing here, hopefully not too precariously close to the edge. Hopefully there's like a guardrail or something there, on the skyscraper, and he's looking down. And that's why I drew it this way. So like angle of depression, we're looking down. So I always draw these right triangles as like a downward right triangle. So here's our horizontal distance across. Here's that vertical distance. This would be the height of the skyscraper. And this is our angle of depression here. So that's the slight difference with these angle of depression ones. So before we were looking up, now we're actually looking down at the ship below. So it's the same exact problem, really, only the triangle's kind of flipped upside down. So let's go ahead and set it up. There's the 945 feet. This is the 67 degrees angle of depression. Obviously, this is not drawn to scale because that doesn't look like a 67-degree angle, but that's okay. And then here's our horizontal distance. That's what I'm looking for, X. How far away is this ship? All right, this is 945 feet. This is 945 feet because we could actually make this into a rectangle, right? And then this would be the horizontal distance down here. So let's label the sides. If this is my reference angle, here's my adjacent side. That's the horizontal distance. Here's my opposite side. That's the 945 feet. Here's the hypotenuse. SOHCAHTOA again. I don't care about the hypotenuse, so I'm not going to use sine or cosine. I actually have to use tangent. So let me get some more writing room here. The tangent of 67 degrees equals 945 over X. This is the exact same setup we had last time. So I'm going to set that over 1, cross multiply, and then I'm going to end up with tangent of 67 degrees times X equals 945. Well, what do I have to do from there? Divide both sides by the tangent of 67, and that gives me X equals 945 over the tangent of 67. So one little shortcut to remember is if the variable is down here in the denominator, you end up dividing by the trig function. If the variable is up here in the numerator, you would actually multiply by the trig function. So that's a little kind of shortcut. Anyway, let's go ahead and plug that into our graphing calculator and see what we get. So 945, let's go ahead and use that fraction again. The fraction function, I like that. So it's alpha y equals, and it was 945 divided by the tangent of 67 degrees. The reason I like this fraction function is you don't have to worry about parentheses and things like that. It's a lot easier to set up your problems this way. I hit enter, 401.13, whatever, 1287 feet. If I wanted that to the nearest foot, I could hit math, number, round, second, little answer, comma, 0. If I wanted to 1 decimal place, my 10th, that would be 1 decimal place. 100th would be 2 decimal places. Oh, by the way, think about this. If they say tenths, think about the number 10, right? How many zeros are in 10? 1, that means 1 decimal place. Hundredths, think of the number 100. How many zeros are in 100? 2, that's 2 decimal places. Thousandth, 3 zeros, 3 decimal places. That's kind of how I remember it. Anyway, so that would be 401. So that would be this distance here, 401. Clearly, I did not draw that to scale because that's longer than this. But anyway, you get the picture. There we go. So that's all I have right now. Thanks so much for watching, and we'll see you here next time. Bye.